Hi, I'm Andreas Ibrom. I'm working at the section The Atmospheric Environment of the Department of Environmental Engineering. Today I want to tell you about the importance of land-atmosphere interactions for climate change. The other day we heard really good news, the emergence of healing in the Antarctic ozone layer. This is a real success story. In 1974, the stratospheric ozone depletion was discovered. In 1987 already, there was a protocol outphasing the production of the cores for the Antarctic ozone hole. 1996, it was completely outphased in the industrial countries, and in 2016 we see the recovery has occurred. This is a real success story, but there are other problems that are maybe even more important, where we have very big problems to mitigate them. And this is the climate change. And here is the CO2 concentration that is rising steadily. It has been measured in the Mauna Loa Observatory since 1958. We know much earlier that CO2 is a greenhouse gas. 1938, there was already a first scenario on the effect. We have 5 IPCC reports from 1990 until now who are telling us what the matter is with CO2, its long lifetime, the big problem of climate change, the huge impacts. There were 22 meetings of the UN, and there was a protocol to mitigate climate change, but it was not very successful. Only in 2015, the nations agreed on keeping the global warming below 2 degrees, but the emissions rise steadily. For the development of climate change, it's very important to look at the fluxes from the surface, CO2 fluxes from the surface into the atmosphere, and also the fluxes from the atmosphere to the ground. And for this, we have developed a method that is called the eddy covariance method, and I briefly show how we are using it. In this sketch, you can see that the air which is coming here is turbulent. So there are eddies that are mixing the air, and they take carbon dioxide-rich air into this willow field. The willow field depletes the CO2, and then the depleted air is transported up. And we measure it here at the tower, the flux that is then representative for the entire field. The data look like this. We have here the time. This is the flux from the atmosphere to the system, downward, negative. And at night, when photosynthesis stops, we have release of CO2 into the atmosphere. Now, I show you some examples how we can use ecosystems to mitigate climate change. Do they take up carbon, more carbon than they release? I show you examples from a beech forest and from a biomass willow plantation. The beech forest we have measured since 1996, and I show you now the cumulated results. So you can see that we started here, the site took up carbon, then it released it from year to year. That is the course that you can see. But it was differently effective. In the beginning, there was almost no long-term effect. So the flux was almost zero. And since a while, the flux is increasing. And we are investigating why. You can see it is a sizable amount of carbon dioxide that has been taken up. Looking at the willow plantation, which we started only later, the results are here, the blue line. And you can easily see that the willow plantation is much more effective to take up carbon dioxide from the atmosphere. The slope is much more steep. In fact, it is 78% higher, the uptake, compared to this phase in our beech forest. So we can use ecosystems to mitigate climate change, forest ecosystems. But we want to take this problem wider. We want to analyze also the activities of men, of us. What are we doing? And for this, we take the system, the eddy covariance system, very high up in 100 meters, and by that we can measure the CO2 fluxes and the other greenhouse gas fluxes in the entire landscape. And you can see here how that happens in this animation. When the wind comes from here or here, then we sample this area, for example here, an area of around Roskilde with the Roskilde fjord, the fluxes from the fjord, from the city, from the agricultural landscape, or from the forests. So by that we will see what is the total emissions, are the total emissions of this area. By that we will supply the people with information how good they are, what they are actually doing, and whether their mitigation efforts are successful, or whether we have leaks, whether we find fluxes that we haven't accounted for. Climate change is a problem that can only be solved when we change our behavior, and this is tough. This is the problem that we face. It is much more difficult to reduce fossil fuel use than, for example, the use of CFC, as in the examples with ozone. And with land-atmosphere exchange measurements, we can help the society to follow up their mitigation efforts and to consolidate whether they are doing right or whether they have to strengthen the efforts. And it would be a really good result if we could show that we have reached the goals in 2020 or 2030, that we have really reduced CO2 emissions. I thank you very much for your attention. Take care.